Sir, I made it. Bhaskar, sir.
Yes, Pradeep ji.
I made you co-hoster. Now you check whether you are able to present the PPT. Now
1 minute.
sharing enabled for you. Sir, I made it. Bhaskar, sir.
Yes, yes, yes. Select the window or screen.
Yes, Pradeep ji. I made you co-hoster. Now you check whether you are able to present the PPT. Now.
Yes, I could able to do it, and it is visible. So could you able to see that?
Yes, sir.
Okay.
Yes, sir.
Thank you. Thank you. Thank you.
Yes, sir.
So good evening, participants. So we can wait for 2 more minutes so that let us give us some chances for the others also to join. And Pradeep, can I say that now this session is available in the YouTube also? Pradeep?
Sir, it is live on YouTube.
Fine, fine. Okay.
I will share that link. So suppose
Okay.
not able to join, they can directly check in YouTube.
That's it. So as the limit is maximum 100 participants in the Zoom. So if anybody is joining in the later stage, so that they can join through YouTube links also. So it is available in the YouTube. So no need to worry about the link is not available or the number of participants are exceeded. Thank you. So kindly mute the participants. Okay. Nandini madam, so shall we start?
Yes, sir, we can start, sir. I will mute all.
Okay. 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 Thank you. So very good evening, participants. So I welcome you all to this today's session through online. So my name is Bhaskar, subdivisional engineer and faculty at RGMTTC Chennai. So I welcome you all to this today's session on power plant and battery. So these are the basic infrastructures required at any of the telecom buildings. So this is about today's session objectives to know about what is this.
Your connection is unstable. That's why.
Daily we have to create the YouTube live.
Live.
Okay.
Bhaskar, sir, please unmute. Actually, you're muted, I think.
Okay, so Correct. So good evening, participants. So today we are going to discuss about the topics on SMPS power plant and battery. So these all are the very basic infrastructures which are required and which are available at almost in all the telecom nodes. So these all are the basic building blocks of a telephone exchange. So in what way these infrastructures are going to be utilized and how it is going to support the telecommunications part. So this is what we are going to discuss today. So I request the participants, those who wants to have any clarifications, they can unmute. So they can have an interactive sessions also. Similarly, if I want to have any questions or if I'm just putting any interactions topics, so that I welcome you all to get interact. And also you can share some information through chat window, so that it will be easier for everyone also to get it to know about your clarifications and doubts. So with all your supports and cooperations, let us start this topic. It is, I can say, it is a basic infrastructure which will be available in almost all the telecom nodes. It could be a telephone exchange, it could be a transmission system, it could be in a mobile tower, or it could be in a training center. We can say that. So that everywhere you could able to see this basic infrastructure, which is something like a kitchen in a home. So which is completely unavoidable, or I can say that unavoidable or inevitable. So that this types of equipments and components are very basic and infrastructure which are essential also, so that to give a perfect and a seamless connectivity to the customers and as well as the telecom services to the users. So now let us start the session. So the objective of today's session is to know about what type of power supply we are using and why we are using only this DC as a power supply. What are the methods we know or we are having it in this industry to convert the available AC into a DC, and the other technologies, how it is getting converted and regulated, and other the testing part. So we are using in our industry. Fine. Let me put a small interactive sessions to all the participants. What type of power supply is available at your home or which is provided by the distribution company? Anybody can able to at least unmute and kindly share. It may be of any state. It could be of Tamil Nadu or it could be of any other states also. What type of power supply and what is the specifications of the power supply? Anyone? Hope that the host has made as you mute, so that may be the reason. Okay.
Alternate current and direct current.
Perfect, sir. I think that only alternating current is provided by majority of the distribution company. I never find in our country whether the DC is getting distributed. I mean, to their end users. You are from, sir. Thank you very much for your response. May I know that you are from which state?
Tamil Nadu, sir.
Tamil Nadu.
Mohammed Sadak Polytechnic College, Kilakarai.
Thank you, sir. Thank you. So that whether anywhere in Tamil Nadu, whether this Tamil Nadu Electricity Board is distributing the DC? I think that to my knowledge, it is
sir,
not.
We are getting
only AC. Very good, sir. Only.
Yeah, only AC and 230.
Exactly. If it is going to be a single phase, it would be of 230 volt. If it is going to be a three-phase supply, it is will be a 440 volt. So normally this is the residential and commercials EB power supply offered by the Tamil Nadu Electricity Board, and almost in all the state board also we are offering or getting this. But in telecom industry, we are using only direct current, that is DC. Let me put the question in the other way. Why the AC is preferred and it is offered to the users by the distribution company? Why not DC? Anyone?
Actually, in a house, we are using AC volt because the one reason is in bedroom we are using AC, then we need that 540 volt like that.
Okay.
And in the hall, TV, different category. That's why we are using AC volt.
Okay, so I understand that there are two ACs are there. The first one is alternating current. Why? And sir is saying about in bedroom we are having an air conditioner. So anyway, good things there. So it is not again the part of the which appliances. It is something like there is a proverb in Tamil. தமிழ்ல சொன்னா உங்களுக்கு முட்டையில இருந்து கோழி வந்துச்சா இல்ல கோழில இருந்து முட்டை வந்துச்சான்றதா. நீங்க ஏசி கொடுக்கறதுனால ஏசி அப்ளையன்ஸ் யூஸ் பண்றீங்களா இல்ல நீங்க ஏசி அப்ளையன்ஸ் யூஸ் பண்றதுனால நீங்க ஏசி கொடுக்குறீங்களான்னு கேட்டா the answer is we are generating alternating current and we are preferred to distribute alternating current only due to the reason of we can minimize the transmission losses with the help of transformers. So that is the major reason identified by the distribution company, so that it has been taken a decision that all the distributions and the transmission has to be done in AC, so that with the help of transformers we can able to step up the voltages, so we can able to minimize the transmission loss. So this is the idea behind the transmission of power supply from the generator stations to the end users. So this cannot be applicable in a DC because a DC cannot applicable or compatible with the transformers, or I can say the transformer will not perform its function like a step up or step down in terms of DC. So because of the availability of AC, so all the appliances are manufactured in terms of AC, so that we are using it in terms of a TV or refrigerations or air conditioners or even ceiling fans. Even though it is a BLDC fans are now more and more popular, that is brushless DC fans are more and more popular, but it is customized to operate only in a 230 volt AC. So that is the reason almost in all the distribution company we are using only AC is the preferred voltage. But in the other way, I can say in case of telecom, we are using only a DC. There should be a reason why the DC is preferred in telecom. I tell you one on one. So now to convert any AC supply into a DC supply, we know that there are some appliances so which can able to convert AC to DC. So as a very basic technology, we know that we can able to use rectifiers to convert alternating current into rectifier current. That is DC, direct current. So the rectifier is in a very beginning idea, and we are still using in some of the areas, but in majority of the industries we are using only SMPS, switch mode power supply, is one of the techniques. It is not much new. Hope that when you were a student, maybe 15-20 years back, or at the colleges or at the early stages of educations, we had a desktop computers. Almost in all the desktop computers, we had a what I can say that we had a system called desktop in the SMPS. It is available in the CPU. So that SMPS is not much newer to the industry, which was a very old, as well as the purpose of SMPS is similar to that of the telecom industry. That means which are used to convert the AC into a DC. So from this slide, I would like to say that so the available AC current is getting converted into the DC. And the purpose of DC will be explained in the next slide. Here, what is the voltage we are going to convert means we are going to have a minus 48 volt DC. So this is getting standardized as exactly how we are standardizing the 240 voltages in a single phase and the 440 voltages in the three phase. Like that, here in telecom industry also we are standardized minus 48 volt. Minus here it's a polarity. So 48 volt is the specifications or standardizations which are available for the what I can say that standardization voltages for the equipments. One minute, let me. Okay, we'll see this one. So why AC is preferred in our telecom industry? So that is what we have to get the reply. So here the purpose of using AC in the telecom industry is DC will not have any ripples or waveforms or harmonics which are not required for any of the communications equipment. It means AC will contain harmonics. Means AC will be having a sinusoidal waveform, so where we can able to have the harmonics, that is unwanted signals, which can be an interferences for the communications. But whereas DC does not have any harmonics. So the relays and electronic devices are very sensitive and which are most compatible for the direct current. So that is also one of the reason we are using DC in our telecom industry. Then another one is, so arranging the standby in the DC or simple, so that with the help of a battery I could able to arrange a DC, so that, and which is less hazardous if I am operating in a low voltages. So that is also one of the reason. So the DC is preferred in our telecom industry. So with the help of the rectifier we could able to convert the available AC into a DC. So the main reason for using the DCs in telecom industries are, I'll name it. One, number one is we are using only a telecom equipments. I mean, direct current appliances and semiconductor devices. We are using it, and DC will not have any harmonics. So that is again another reason. The third one is we can able to save DC with the help of batteries. So, and one more point, I would like to say that here we are not going to use the two terminals of the positive and negative. Here we are going to earth one of the terminal, which is namely a positive electrode, so that we can use only a negative electrode for the distribution spot. So that is the reason we are able to say that it is a single pole switching, or the one pole will be earthed. So in the other way also, which is similar to that of our electric train. So where you can able to see only one conductor which is carrying around a 25 kilovolt of AC supply. So the secondary cable will be of the rails, the train which is running, right, the rail. So that it is a single pole switching. So the advantages of single pole switches are, we can avoid the crosstalks and other disturbance with the help of earthing one of the terminals, and to make the alarms and supervisory easy, so that we no need to run on a secondary cable as a written cable. So with the simple one single cable we can able to identify or get the alarm status.
So excuse me, sir.
Yes, please.
So have you changed the slide? Still, I could see one first slide. Have you changed the second or third
Yeah,
slide?
I have changed this. I have changed the second. That is why earthing on one pole.
No, I could see only the first slide, initial slide. That's why I'm asking.
Oh, okay. Let me see.
Okay, sir.
I think now you could able to see that.
Yes, sir. I could see now.
Okay. Okay, sir. Thank you. Thank you. So this is the first screen. I'm just showing you this, why the power plants and rectifiers are used. And this is the next slide. I'm just trying to say that why the DC is preferred in the telecom industry, which does not have harmonics and which is compatible for the semiconductors and the relays. And arranging the standby with the help of battery is easy in our DC. And the next point I said that we are not using the two cables in the DC. We are earthing one of the pole or one of the terminal. We are using only one terminal is for the connectivity. The reasons are, I said, like we can avoid the crosstalks, we can put the earthing, and we also can use it for the written alarms and supervisories in a easy methodology. And out of the positive electrode and negative electrode, we are earthing the positive electrode. So with the help of the trial and error and as well as observed in the manufacturing part and the recycling part, we have observed earthing the positive electrode is preferred. The reasons are, so to minimize the corrosions of the positive electrode. If suppose positive electrode is connected to the load, the corrosion happening at the battery terminals of the positive electrodes is relatively more compared to that of the electrode which are connected to the negative. So partial earth faults can be easily detected. So with the when the positives are earthed. So similarly, we can able to minimize the corrosions of positive lines used in the older line. That means it has been exposed in the open wire system, like the telegraphs and other methodologies. So that is the reason out of the two polarities available in the batteries, so we are earthing the positive. So we are using only negative terminal. That is the reason we are saying in telecom industry we are using only minus 48 volt DC. So this diagram shows about the conventional power plant. It means with the help of the rectifier model, transformer models, we had a three part. One is a float rectifier, another one is a battery charger, then switching cubicle. So as put together, so it will be of bulky in nature and it occupies more space and weight. So which was a conventional and old methodology. And one more disadvantages with respect to the old or conventional rectifier model is that we cannot able to have a flexible size or flexible architecture. Suppose by today I may be using one module for some few loads, but tomorrow I may need more uh, equipments or I can need more demand of the load. So the same power plant could not able to flexibly added or increased or decreased based on my load requirement. So that is also one of the difficulties we faced in the rectifier. So it is always available with the maximum size. So we cannot reduce it or I cannot increase the capacity of the plant. So all these things are overcome with the help of the latest technology called SMPS power plant, that is switch mode power plant. So very normal in the conversion of AC to DC, we used to do this, right? So we will step down the voltages of AC to the DC. I mean, with the help of transformer, we can able to convert. I mean, step down the AC from a higher voltage to the lower voltage. Then, with the help of the rectifiers, either it can be a uncontrolled rectifier like diodes, or a controlled rectifiers help like a SCR, silicon controlled rectifiers. We could able to convert a bidirectional into a unidirectional current. Then with the help of the RLC, resistance, capacitance and inductance, we can remove the ripples so that to make a steady state DC value. And finally, we can able to have the regulation so to expect to give the expected output. So these are the very basic methodologies we used in our conventional power plant. So there are two types of regulations method. Regulations in the sense how we can able to control the output with respect to the expectation of input. So there are three modes of operations with respect to the battery charge. The point number one is it is a charging. The point number two is it is a discharging. Point number three is floating. It means which is maintaining the maximum voltage always. Similar to that of our charging our mobile with the help of charger. If your mobile is having only 20% of the charge, by putting the charger in the power supply, so your mobile will get charged from 20 to slowly gradually increasing 20, 30, 40, 50, etc. After reaching the 100, what will happen? It will be holding it on 100. It means that is called floating state. If you are removing the charger, now the battery is getting discharged. So these three conditions are there in our uh, charging mechanisms or in the battery charging procedures. So that has to be adjusted automatically. In what way we can able to use the regulation methods. In SCR, silicon controlled rectifier regulations, hope you may be knowing about the basic control of triggers. So there are two terminals, anodes and cathodes, and which are controlled by a terminal called gate. So with the help of the pulses, we can able to switch on the SCR. So with the help of delaying the gate pulses, we can able to control the output voltages or the connectivity conducting time. So like that we can able to have the regulator so that we can able to change the output voltage based on the requirement. So this is one of the regulations methodology. So by changing the time of the gate pulse given to the SCR. So I can able to change the output voltages and current accordingly. So now we'll come to the current technology of what we are using it in our industry. So that is a SMPS, switch mode power supply. So it is working in a efficient mode and also which is reliable in our industry. Like in the third point, I would like to say that which is a highly reliable, which is a highly efficient, noiseless, which is very compact, and also which is flexible with respect to the demand of the load capacity. So as I said that if I need only a limited number of current for this current time, so I can use one module. Maybe if I need more loads, I can increase the number of modules based on my requirement. So such a flexibility is available in the SMPS power plant. So the idea is here we are using the MOSFET and IGBT. These are the different types of transistors, so which are semiconductor devices. So by having a high fast switching and which makes a higher control efficiency, so that we can able to get the conversion of AC to DC, and also we are getting all these benefits like high efficiency, reliable, noiseless, and compact. As an industry friendly, I would like to say that the space and cost are the more attractive part of the SMPS. And I have already quoted that in all the desktop computers, in the CPU, you could able to witness or see that there is a small square box which is nothing but same SMPS, which is converting the 230 volt AC into a various DC voltages which are required for the computers, motherboards, or hard disk drives, or other different network elements. So here also we are converting the AC into a DC. As required, we are able to expect a minus 48 volt DC. This is again the repetition. So the advantages of SMPS power plants are it is a highly reliable, efficiency, noise free, and compact and cost effective also. So the power loss is also minimum. That is why it is more efficient. So what it could be the inside the SMPS, we'll see one by one. So this is the basic block diagram and it's a functional block diagram. So how the AC is getting converted into DC is explained in this diagram. So here the AC, the normal 230 volt single phase or 440 volt three phase is given as an input. It is first converted is with the offline rectifier. That means it is not having any control. So it is just converted into a DC. It's a pulsated DC. Then it is getting stored in a capacitors to maintain a non-pulsated DC. I can say that like a regulated DC. Then the point number two, where the switching function is coming into the picture. So here we are converting that DC into a pulsated AC. So why I'm converting it to AC means in the earlier in the first line of AC we are having a 50 hertz of frequencies, but here at the point of power switches, so we are going to convert into a high frequencies of ACs. Normally we are using around 25 kilohertz of AC. Here the range has been given from 100 to 6 megahertz, but normally we are using 25 kilohertz. So high frequency AC is produced. So the reason for high frequency ACs are we can able to reduce the size of the transformers, as well as we can able to minimize the efforts for regulations part, so that it will be having a more steady state DC value. So that is the reason we are switching to the high frequency AC. Then the stage number 4 is there, so that we can able to convert back into the DC. So I cannot expect the Tamil Nadu Electricity Board or any other boards to give me a high frequency AC because it is designed for 50 hertz. But to have an efficient and space effective and very much controlled rectifier, so we are increasing the AC by converting AC to DC first and DC to the high frequency AC. Then from the fourth stage, it is converting back to the DC and it is getting filtered and I'm getting the DC output. But to maintain the expected DC output, like a regulations part, so there will be a closed path. So we used to know about the PLCs or other controlled back systems, so that we are able to get the references from the output and which is given as a reference model. So what this output has to be maintained For example, the 48 means the 48 has to be maintained at even any changes with respect to the input or any changes with respect to the load. The load may increase or decrease, input voltage may increase or decrease, but I have to adjust my output voltage, which is expected to be at the same constant 48 volt. So for which this control circuitries are available. So accordingly, which will automatically adjust the pulse switches switching on and off time, so that we can able to get the expected output. It's like in the same simple closed central control circuitry. So next is this is about the same model with respect to the waveform model. The very first one is we are having an AC sinusoidal, then it is converted into a DC. So now that is again converted into a high frequency of AC. AC in the sense here it's a pulsated AC. It is not a sinusoidal AC. It's a pulsated. It is again converted back as a rectifier model so that we can use it as steady state controlled output. Hope these diagrams and the principle is understandable by the screens and the earlier screen. Shall I proceed, sir?
Yes, sir.
Okay, madam. Thank you. Thank you. This is again a part of the SMPS power plant. So this is explaining that how the duty cycles are adjusted and how the transistor is able to be acting as a switch. So here it is a base current. So with the help of these pulses, so this transistor can be act as a switch so that the input can be passed on to the output. So SMPS means switch mode power supply. Here the transistor is acting as a switch to convert AC into a DC and as well as DC into a AC so that we can have a high frequencies of AC. So how I can able to vary the output voltage or maintain the output voltage based on the variations in the incoming and outgoing means it has to be sensed by the output and it has been controlled by the control circuitry and it has to be feed a basic input current to the transistor to change the on and off times. So we'll see this from this diagram. So here you can know it. If an input voltage is 200 voltage and the D is called a duty cycle. It means if I am operating the duty cycle at a 0.25, then the output voltage would be of only 50 volt. Instead of having a step down transformers, which could be okay in our AC, but in DC, with the help of the duty cycle, like on time and off time variations, we can able to change the output voltage. So here the regulation is achieved by modification of the duty cycle. So how long the transistor has to be in switch on and how long it has to be switched off will be done with the help of the pulse that is given to the base. So that is why it is called a pulse width modulations techniques. So to change the pulse, we have to get the references from the output of the SMPS module. So this is about the reference model. So this okay. So this relaxation oscillator and integrators are the references. So that is given to a comparator. So that this sawtooth model can able to change the references model so that the width of the on and off, that is base current, can be varied. Accordingly, the duty cycle of the transistor can be varied. So if more pulses will be there, more on time. So less pulses will be there, it's a less on time. So accordingly, switching time and on time, that is the duty cycles, can be varied with the help of the this integrator, relaxation oscillators, and the comparator. So comparator is nothing but which is taking a sample from the output. Accordingly, if the output voltages are lesser, so it has to increase more base time current so that the on time will be more. If the output voltages here is higher, we have to reduce it so that the duty cycles will be adjusted in such a way that the base current will be reduced so that the on time will be reduced. So like the simple reference model. So this base current of the transistors are adjusted and accordingly the on time and off times are varied. Hope it is an
Can you please
uh,
Sir, can
yes,
you
sir.
please explain what is duty cycle, sir? Actually, I am unaware of
No issues. No, I
this
tell you, sir.
new
I tell you, sir.
technology.
I tell you, sir. So duty cycle is nothing but how long that output is going to be availed. That means if there is a switch in between your input and output, so if the on time is more, the output will be more. If the off time is more, the output will be less, or in the vice versa, whatever it can be. Suppose to have a more output, my on time is more, or I need to have a maximum base current for this transistor. So just by varying, you can able to. I will show you in this way. I can show you from this. Yes, from this diagram, could you able to see this output waveform? If suppose
Yes, sir. Yes.
if I'm triggering this transistor or any of the switching devices at this part, this blue shaded part is your output. If I need more output, what should I do? I have to trigger the angle at the earlier stage, even at the 0. So I will be getting the full output. If I want to have only 50% of the output, what should I do? I have to switch on the part at exactly 90°. So then I will get only the 50% of the output. So like that, the duty cycle says about by having maximum on time or off time, it is decided by at which time you are going to make a switch on or off. Or in the very simple, if make it as an example of 100%, after that, how much is going to be in on? Maybe if I'm having 80% of on time means, so my output will be of 80%. My on time is only 10% means my output will be of only 10%. So that is called a duty cycle. So out of the available input of duty cycle, that means by advance to the output. So I think the example எடுத்துக்கங்க ஒரு half waveform எடுத்துக்கங்க. இப்போ நான் எந்த இடத்துல நான் ட்ரிகர் கொடுக்கறேனோ அங்க இருந்து அது சுவிட்ச் ஆக்ட் பண்ணி that my input is goes to the output. If I'm switching on at exactly at the mid of the waveform, that 50% of the output will be passed on. That means only I'm sending the 50% of the input to the output. Is it clear, sir?
Sir, actually, suppose
Shall I
if
proceed, sir? Is it clear?
am I audible, sir?
Okay.
Hello.
Thank you. Yes, sir. Yes, sir.
Sir,
You're audible, sir.
If the input is given at 90°, that means what is the duty cycle value, sir?
Okay.
Is it 0.5?
It is a 50%. It's 0.5. Yes, exactly. 50%. That's it.
Yeah.
It's a simply percentage. Yes, you are right.
Yeah, okay. So I want to see in terms of.
No, here I just mentioned about if the duty cycle is 0.25, it is a 25%. Exactly, you are right, sir. It's only percentage of output. Duty cycle is nothing but how much percent. That's why I said here it is of 25%, means 25% of the 200 is given as an output. It means a 50 volt. If my duty cycle is 0.5, my output voltage will be of 100 volt.
Okay, sir.
Clear? Fine. Okay. So that this is how we can able to put the references. So what is my expected output voltages and how it is getting variated. All these things are with the help of the comparators modes and the reference model. So this is why it is called the pulse width modulation. So now coming back to our industry arrangements, we are having a different types of SMPS power plants. It means based on the capacity. So here we have got two types of voltages. One is float voltage, another one is charge voltage. So I told you that our expected output voltage is minus 48. But to maintain that 48 volt, because you will be knowing about there will be internal loss, there will be internal resistance, there will be efficiency parameter, there will be of different transmission losses from the battery to the load. So that it has been decided. So to maintain the voltages of 54 plus or minus 0.5. This is what the desired voltages for the maintaining the batteries. But to maintain the batteries again, or to during the charging, so that the current has to flow from the SMPS to the battery, so the charge voltages will be slightly higher. So that means 55.5. So it says about charging voltages will be larger, floating voltages will be a moderate, and finally the desired output voltage is minus 48. So that means we will be having an internal loss, it will be having a transmission loss, it will be having a regulations, and finally you'll be getting a 48 volt output. It is நம்ம எப்படி சொல்லலாம் அப்படின்னா ஒரு வெஹிக்கிளை வந்து ஒரு ஷோரூம்ல வச்சிருப்பாங்க. ஸோ த வெஹிக்கிளுடைய மைலேஜ் அப்படின்னா 100 கிலோமீட்டர்ஸ் பெர் லிட்டர் அப்படின்னு சொல்லுவாங்க. பட் இஃப் யூஆர் ரைடிங் இட் ஆக்சுவலி அப்படின்னும் போது அவங்க சொல்லுவாங்க சார் இட் இஸ் ஆன் ஸ்டாண்ட் அப்படின்னு சொல்லுவாங்க. தட் மீன்ஸ் ஸ்டாண்டை போட்டு நீங்க ரன் பண்ண அப்படின்னு சொல்லுவாங்க. இட் மீன்ஸ் ஸோ தட் வில் நாட் பி ஆன் ரோட். So if you are coming to on road, then they will be saying about it is a continuous transition. You should not have the speed breaker. You should not have a stops and start. You should having only single passenger. Every conditions are so like that. So on road, 48 volt varno abdina, we should have a maintenance of at least 54 volt. So then only there will be loss in the batteries, a transmission loss in the cables, and the regulations parameter overcome. So finally, we'll be getting a 48 volt. So in the bottom three lines are there. These are all the different capacities for single phase and three phase. These are all the DC current. So the capacity could be of 25 ampere or 100 ampere or 200 ampere. So just by identifying that, you could be seeing that how could these hundreds and 200 amperes are possible. As we are converting the AC into DC and converting that 440 voltage into 48 volt, so the current will be increased for the same power. As we are reducing the voltages, the current value will be increased. Dear participants, kindly mute if you are not having any doubts. So these are the types of SMPS power plants that are available in our industries. Just by maybe at the field visit, you may be going to the nearby exchanges where you can able to see all these power plants. And you can able to see the thickness of the cables also, because the AC cables will be of very normal case, normal size only. But the DC cables are looks like very so thick cables, because it has to carry about hundreds and 200s of amperes. Though the voltages are less, to maintain the same power, so the current rating will be of higher, so that to carry more current, the thickness of the cables also very thick. So that it will be of in terms of cross sections, I could like to say it is nearly 1.2 centimeters or 1.5 centimeters also. And depending upon the various parameters, the power plants are designed with load current. It could be of 100 ampere current, or it could be of 200 amperes or 400 amperes or 600 amperes, like that. It has various ranges are there. Accordingly, we can add numbers of modules. And the required recharge time, battery size, and many things, we are having the different types of power plants, designs and sizes. But as I said, dear participants, kindly please mute yourself. Madam, kindly mute. Okay. So based on the other various parameters, how much backup time I want, and how much loads I have, and what are the different types of batteries I'm using, it like that, with the help of all these parameters, the power plants are chosen, or we can able to design it. So this is an example of an SMPS power plant racks. So this right side image, you can able to see that there are two racks are there. So out of which each and every rack is having a sub modules or racks. So these individual racks could able to support 50 amperes of DC current. If suppose I'm having around 12 racks are there, so it will be able to support 600 amperes of DC current as a put together total. So totally 12 racks will be there, and finally all the 50 amperes of each can able to support 600 amperes of DC currents. And as I said, it is a more flexible and compatible for the higher range and lower ranges of requirements also, so that if loads are increased, I can add more numbers of modules. If my loads are reduced, I can reduce the numbers of modules. So accordingly, I can have a flexible architecture, so which is an advantages in our SMPS power plant. So these types of flexibility is not available in our conventional uh, rectifier model power plant. This is a circuitry available in our SMPS power plant module. It will be having a rectifier, primaries and secondaries and main filters are there. And this is one of the testing, it will be done in our SMPS power plant. So before putting into the field, so after the installations part, our acceptance testing teams will be there like a QC, quality check. So they will test the power plant whether it is perfectly installed, whether it is capable of handling the loads, or so they will provide an artificial load. So before directly connecting to the telecom loads, they will provide the artificial loads, and they will verify the installations of both AC and DC part. They check all the other controls and monitoring parameters. Then they will certify that it is perfectly fit for the installations. So that is we used to say about acceptance test or AT. So first they will do the installations test. So it means both AC to the body or like DC to the body or the AC to the DC. All these things are done with the help of Megger. So this is the Megger. So that is called installations test. Then they will be verifying that alarm test, whether the under voltages, over voltages, over current, or high frequencies, or module failures, or any temperature variations. So all these things will be verified with the help of alarm test. There is one critical alarm is there in our SMPS power plant. Normally mains on battery discharge. What we normally expect that once the mains are available, there is supply is available, so that has to be used for charging the battery. So battery should not discharge. But there are some critical times or some false things that even though the mains are available, the battery starts discharging. So nobody could able to identify that the battery is discharging it. Only after the failures of the equipment only we came to know that. So like that, there are some critical alarms are there like mains on battery discharge. And finally, we are having the efficiency test. So it means how the efficiency, I mean the SMPS power plant is performing and what is the efficiency. So from conversion of our input to the output, how much is wasted as a loss in the power plant can be identified. So the output is a DC, it is voltage into current. Input is a AC, voltage current into the power factor. So that is a conditions or formula we can able to get the efficiency. As I said, relative to the conventional power plant, SMPS power plants are having a higher efficiency, more than 85 to 90% each. And the another term is called a drooping. So the change in the output voltage with respect to the change in the load current. If the load is goes beyond 110%, that means if the power plant is designed for operate at 200 amperes of DC current. If I'm exceeding the 200 of DC current, what will going to happen in my output voltage? Whether the output is going to maintain the same 48 or if it is going to be reduced. So that is called a drooping. So if it is of higher more current beyond the limitation, there should be a safety and security provision so that it does to isolate. Otherwise, what will happen? So the battery may drain continuously, or it can cause a problem to the equipments also. So that it has to be get isolated. So that is called drooping. So as I said, we will first test the SMPS power plant with the help of artificial loads. That is called heating coil. So this heating coil is acting as a load, so that they will switch on the SMPS power plant and they will do all the measurements and testings. So they will not directly connect to the telecom equipments, because here we can able to change the loads by having the variations of length of the cables. So it is an artificial load, so that with the help of this we can able to test. So here the heat runs are done for nearly 8 hours. So it will be validating that whether it is a continuous operating or continuous rating equipment or not, because it has to be work always. It is not on a secondary. It should be a main part of the exchange. So it has to be tested for the continuous rating, so that nearly 8 hours of loads will be applied as a full load will be applied, and it will be validated in the acceptance test. So hope that basic idea is given to you. So that the purpose of power plant is to convert the available AC into a DC. So that is designed for 48 volt of DC. So why we are using a DC is that the DC will not have harmonics, which will not have any interferences, which is compatible for all the semiconductor devices. And also this DC can be storable with the help of batteries. So these are the reasons we have preferred DC. So to convert the AC into a DC, so in our current scenario, we are using SMPS is the power plant, or it is a technology to convert the AC into a DC. So in that we are having a different types of shelves and models are there, and different ratings are there, and we are having a testing is also there to test and validate the power plant. So can we have a small interaction that we may be having a small questions pattern so that we can check. So we have discussed about two types of voltages, that is a float voltages and charging voltages. I said the float voltages will be moderate, charging voltages will be higher. So then only the batteries will get charged. Even இப்போ கூட நீங்க யாராவது vehicle battery charge பண்றீங்க அப்படின்னா, so like your car battery or your two-wheeler battery, so there they will used to say that yes நான் boost charge கொடுத்து பார்க்கறேன்னு சொல்லுவாங்க. Boost charge means higher voltages than the normal voltages, so that there are some chances for regaining its position. So from the participants, anybody can able to come and say that what could be the float voltage we have discussed?
55.2 volts, sir.
55. So that is a charging voltage, madam. Thank you very much. So it is a it is a float voltage. It will be a 1 volt lesser. It's a 54. Thank you very much for your participations. So that's why I said float voltage will be moderate, charge voltage will be the maximum. Thank you. Let us have another chance. So what is the charging now? I have already revealed the questions. So what could be the charging voltage now?
55.2.
Exactly.
Yeah.
Thank you, sir. 55.2. Exactly. Thank you, sir. Thank you very much. So the efficiency of the SMPS should be greater than 90 at full load in the normal output. Normally, any equipment is designed to have their efficiency at nearer to the maximum level, not exactly the maximum level, nearer to the maximum level. So is it a true or false?
True.
True, of course. That's why I said it is in general of any manufacturing equipments. So which will be having its efficiency nearer to the maximum. It's not exactly at the maximum. Even as I said, if you are having the car, they will be saying about if you are riding around 75 to 80, you will be getting the maximum efficiency or maximum mileage. If you are crossing more than 100, though the speed will be more, but the diesel consumptions and the mileages will be lesser. So like that. So if you are operating at least the 90% of the full load, you will be getting the maximum efficiency. So which is working on what principle? SMPS power plant is working on. Let us see that. Switching regulations principle. So just by changing the duty cycle, on and off duty cycle changes, I could able to achieve the output voltage. And few more questions are there. In SMPS, that is in switch mode power supply, the maximum efficiency of the duty cycle should be less than. Let me show you the answer. It's a 0.5. So because if the duty cycles are less, means here it is lesser than this, the output will be maximum. The SMPS rectifier model, this much of works on what voltage. So it can have any range. That means input voltage could be normally from three-phase voltages. Because of this 560 watt will be of a three-phase voltage. So three-phase voltage can have the variations of 320 to 480 voltages also. So the bus bar or the cable chosen for the load path. So that is connecting the batteries and power plants to the load. So we are having a dash the percentage of the capacity. We can go at least to the 70% of the ultimate capacity. So I would like to explain that what is ultimate capacity. So the power plant as a whole, which can be having the ultimate capacity, but in which the numbers of modules are decided based on my load capacity. I would like to say that இப்போ என்னுடைய எக்ஸ்சேஞ்சஸ்ல ஒரு பவர் பிளான்ட் மாடியூல் வாங்குறேன், அதோட அல்டிமேட் கெப்பாசிட்டி வந்து கேன் ஏபிள் டு ஹேவ் 6 numbers of 100 ampere capacity. So that is an ultimate capacity. But I may not have all the 6 modules are activated. What I can have, I may be having only 4 numbers, so that the maximum load current can be 400 amperes. So that is the difference. So ultimate is the overall capacity, like the maximum demand we are quoting in our EB department. But whereas the consumed load is nothing but how much modules are available or how much modules are used. That's it. So that is the differences. So hope that basic idea is given for SMPS power plant. Now we will go to a next topic. So here also there is one more question is there. Power system controller can set the plants to work in dash modes, 3 modes. So one is a discharging, another one is a float, another one is a charging mode. These are the 3 modes. So now we'll come to a new topic called battery. இந்த பேட்டரின்னு சொன்ன உடனே எத்தனை பேருக்கு ஃபகத் ஃபாசில் மைண்டுக்கு வந்தாருன்னு தெரியல. யாராவது வந்திருந்தா நீங்க தம்ஸ் அப் போடுங்க, ஐ கேன் அண்டர்ஸ்டாண்ட் இட். ஸோ அட்லீஸ்ட் யூ ஹவ் சீன் த மூவி அப்படின்னு நான் நோட் பண்ணிக்கிறேன். So, but we are going to discuss about the real battery, not the Vatian battery. Okay, fine. Can anybody able to say that what is called a battery? எல்லாருக்கும் தெரிஞ்ச விஷயம் தான், but I just want to make that you are getting involved in this session.
Storing charges.
Storing charges. Okay. இதுல ஒரு small changes sir. The charges அப்படின்றதுக்கு பதிலா என்ன சொல்லலாம் அப்படின்னா, normally we used to say capacitor is used to storing the charges ன்னு சொல்லுவாங்க. But here we can say here it is to charge energy ன்னு சொல்லலாம். That is ஒரு power. Perfectly have given the information. So we can able to say that the battery is nothing but it is a cell or it is a storage device which can store electrical energy into a chemical energy. In the reverse case, which can discharge the electrical energy into a chemical energy into a electrical energy. So this is what it does. So while charging, it is converting the electrical energy into a chemical energy and it stores a chemical energy. And in terms of the discharge, it converts the chemical energy into an electrical energy. So this is the technical definitions of any battery. But there is one more definition is there for battery, which is in English. So batteries are nothing but this is a group of cells. As I told you that we are using a 48-volt battery. So that is maintained for our telecom industry, and that is the voltage we expect. I cannot manufacture a 48-volt of battery as a whole or a 48-volt of cell as a whole. So what I could do, I can manufacture a cells of an unit value, maybe like a 2-volt per cell. So then I can able to make a series of 2-volt per cell of around 24 numbers to make a 48-volt battery. So எனக்கு ஒட்டு மொத்தமா ஒரு 48 வோல்டேஜ்க்கு ஒரு செல்ல உருவாக்க முடியாது, because that will be so heavy and so bulky. So what I can do, I can able to make a 2-volt cell so that I can able to have a series of 24 numbers of 2-volt cell to make it 48-volt battery. So this is what another terms. Maybe if right, or you can able to clearly understand from your ancestors also. So that what I would like to say that இப்போ உங்களுடைய வீட்டுல பெரியவங்க தாத்தா இல்ல கிராண்ட் ஃபாதர்ல இருக்கும்போது என்ன சொல்லிருப்பாங்க அப்படின்னா, அந்த டார்ச் லைட்டுக்கு பேர் பேட்டரிஸ்ன்னு சொல்லுவாங்க. They never say the word like torch light. அந்த பேட்டரி எடுத்துட்டு வாங்கன்னு சொல்லுவாங்க. It means what? அந்த பேட்டரின்றது அந்த டார்ச் லைட் குள்ள பாத்தீங்கன்னா it will be having 2 or 3 or even 4 cells will be there. So that is the reason, as it has got more number of cells, it is renamed as a battery. So that is the reason. இப்போ அந்த olden periodsல அந்த உங்களுடைய grandfather அந்த peoples என்ன சொல்லிருப்பாங்க அப்படின்னா, they never use a torch light, they used to say that it is a battery because it is having a more number of cells or more than one cells. Cell நான் சொல்றது உள்ள இருக்கிற small secondary cells. So that is what we are going to have discussions in this battery sessions. Let me put the questions again to all the participants. What is the backup you are using at your home in case of the power failure? Anybody? What all are the different UPS? Very good, sir. Super. Anybody else is having any other methodology?
Generator.
Generators, very good. It is a generating part. Yes, very good, sir. One is UPS, another one is generator. Normally for your home, for your residential purpose.
Residential
Inverter,
purpose generally
sir.
UPS only, sir.
UPS, very good, sir. So sir is using UPS, madam is using inverter. Very good, sir. Perfect. Maybe for the other audience also, it may be knowing part, but I'm giving a questions to again all the participants. If I'm having a two options, one is UPS and another one is inverter, what could be your choice for your residents?
UPS.
UPS, very good.
UPS.
But in the industry or in the general, I don't know, but as if you are having a statistical informations, more than 80% of the homes will be having only inverters. Am I right? Only very few may be having a UPS. So why
Yes,
the
sir, yes, sir.
inverter? Why the inverter model is preferred? Why not UPS? Or what is the definition of an UPS? That is expansion of an UPS.
Uninterrupted power supply.
Very good, sir.
Uninterrupted power
Excellent.
supply.
Thank you, sir. Thank you. So UPS stands for uninterrupted power supply. But why the inverters are utilized or inverters are, I mean, majorly deployed in our residential purposes? Where inverter may have an interruption. Both are having a batteries, both are having a circuitries, both are getting the same input. But why the residential parts are having an inverters? Why the UPSs are only very limited and restricted places only we are using an UPS? Okay, let me tell. As pointed, someone is pointed very correctly. That is UPS stands for uninterrupted power supply. So தடை இல்லாத மின்சாரம் அப்படின்னு வேணும்னா your choice should be UPS. Let us take two examples. Example number one is a tube light. Example number two is computer. Of course, it is a desktop computer. So tube light ஒரு தடவை ஆஃப் பண்ணிட்டு ஆன் பண்ணும்போது எந்த ப்ராப்ளம் யாருக்கும் வரப்போறல. டியூப் லைட்டுக்கும் ப்ராப்ளம் வரப்போறதுல நமக்கு எந்த ப்ராப்ளம் வரப்போறல. That means if you are switching on and switching off the tube lights, nothing is going to happen to tube light and as well as to any of the environment. Just compare the same example to the computer, which is a desktop computer, which is in on conditions. Is it okay for just switch off and switch on? Whether is everyone will be okay? Whether the data are okay? Whether the hard disk drive and other motherboards will be okay?
Yes, sir, yes, sir.
So are you getting the differences? If the loads are critical, even if it does not allow a fraction of seconds of power failure, it always expects an uninterrupted power supply. So our choice should be UPS. That means uninterrupted power supply providing services called UPS. If the non-critical loads like a TV, like a refrigerator, like an air conditioner, I can say like a tube lights or fans or etc., like majority of the home appliances, these all are non-critical, so that we can go for inverter mode where small interruptions are allowed. We're getting the differences. Whenever the loads are critical, which never expects a failure, so the choice of our backup should be UPS, that is uninterrupted power supply. Wherever the loads are non-critical, even if small interruptions are allowed, it never going to make any problem to the environment and as well as to the equipments. So our choice could be an inverter because of the affordability class. That is because of the cost effectiveness, not because of the technology. So clear, sir? Fine. So now let me put the question the other way. What makes the difference to give an uninterrupted power supply by the UPS? So both are having a battery, both are having the circuitries. Then what made the logic, or which logic made the UPS to be providing an uninterrupted power supply to the loads? Am I audible, sir?
Yes, sir.
Okay. So may I get any response for this question, so that which logic makes the UPS to provide uninterrupted power supply to the load? Okay, so let me tell the example, or I can give a small easy example for you to understand it in the right way. So you are having a mobile and it's a charger and also power supply is available. So you are connecting the charger to the mobile phone and you are connecting the charger to the power socket and you're switching on. So what will happen to the mobile? It is getting charging, right? If you are switching off the power socket, that is switch off the plug, whether your mobile will be goes to switch off or it will be still in on condition.
On condition.
On conditions. Exactly. Perfect. Thank you. So how it will be still in on condition because the mobile does not rely on the external power supply which is provided by the electricity board. It is a purely rely on the local power supply which is already having or stored in its own battery or cell. So this is the logic behind the UPS and inverter. If the load is purely depend on the internal source like batteries or cell, that is called UPS model. Whereas the inverter model, the load is purely depend on the external source. When there is a failure is detected in the external source, then it will switch over to the internal source, that is like a battery. So this is the basic logic difference behind the UPS and inverter. Hope you're getting the point, right? If you are having a UPS for your computer, maybe desktop computer, the computer will work only rely on the battery source, not rely on the external power supply. As long as the external power supply is available, that is used by the battery to getting charging and keeping its charge maintaining. Once the failure of once the external supplies get failed, so this battery will keep on discharging, which ensures that nothing is getting disturbed to the load. That means it is always providing an uninterrupted power supply. So this is the logic behind it. So why I'm trying to say this means in telecom industry, all our telecom equipments and switches are also critical loads, which has to be maintained with any with all the maximum uptimes. So we have to maintain uninterrupted power supply. So the idea behind the uninterrupted power supply means, so the load will be always connected to the battery backup, and the battery backup is always connected to the external power supply with the help of SMPS power plant. So at any point of time, the load will be always maintained with the maximum uptime, so without any interruptions of the external power supply, right? So this is the purpose we are using battery in our telephone exchanges or in almost in all the places. But at residences, because of the affordability, as I said, because of the cost effective nature, though the UPS methodology is available, but we are not pointing all the loads are critical loads. So we are neglecting the non-critical loads, so that we are using inverter model. So that, okay, so இது ஆஃப் ஆனால ப்ராப்ளம் இல்லை, ஸோ அதனால எனக்கு அதுக்கான பேட்டரி பேக்கப் வேண்டாம், ஸோ குறைவான பேட்டரி பேக்கப் இருந்தாலும் எனக்கு போதும், ஐம் ஹேவிங் ஒன்லி வெரி லிமிடெட் கிரிட்டிக்கல் லோட்ஸ் அப்படின்றதுனால UPS models are segregated. So inverter models are more popular in our industry. Hope I made it clear about the logic of both UPS and inverter. In terms of the battery, so there are again two types of batteries are there. One is the conventional batteries. Almost in majority of the residents per home la pathina, you will be having this conventional batteries. But in terms of industry, so we will be having new types of batteries. We'll see one by one. So to provide the uninterrupted power supply, so we need to have a backup source, or we need to have an equipment to store the supply. That is why in the initial slides I told you that we have preferred the DC because it can be storable in the batteries. So batteries are the secondary cells. So the combinations of the battery and the additional backup is called a prime mover, that is generator sets. So we will be having a couple of these, that is one is battery, another one is the generators. So at any point of time, we would like to have the complete power supply to all the equipment, so that to ensure uninterrupted power supply. So the secondary cells are electrolytic cells, because electrolytics means there is a chemical reactions, that will be anodes and cathode, electrodes will be there, so it will be immersed in electrolytes. So these all are the basic chemical process, so which are converted into an electric energy. So it is a vice versa. So in the charging state, as I said, this electrical will be converted into the chemical, it getting stored, and in the discharge condition, the process are reversed. So what all are the basic requisites or the need of good cell? So there are some few requirements are there. So then only we can able to use that as a material for cell manufacture. So there should not be any wastage of material when the cell is not delivering the current. It means the internal resistance should be very, very minimum. It should not consume its own power. That is the first requirement. The EMF, electromagnetic force of the cell, must be such a magnitude so that it has to enable the cell to deliver the reasonable amount. At least the output should be in a reasonable amount to be utilized by the loads. So such an ability it has to be, because there are some reasons even our body can able to say that which can emit some electricity that cannot be used by any of the appliances. So this much of magnitude is a requirement. Frequency of replacements. So at least the lifetime of the batteries and the cell material should be of at least 3 years plus or more. So it will be of reasonably cost effective and which can be used by many of the users. And the same of internal resistance. So it should not have much higher internal resistance, or otherwise the consumption of the load will be more with the internal itself, so that which will be having more losses. So there are majorly 3 to 4 types. And now I can say that even the lithium ion is also added, but in major industries, because lithium ion is very recently evolved and we are slowly adding in our industries. Not it is available everywhere. We are slowly adding in our industries in ratios or in a very small percentages only. But in general, these are the 3 types of secondary cells, or I can say the batteries are available in our industries. The number 1 is lead acid battery. Number 2 is nickel ion alkaline batteries. The number 3 is nickel cadmium alkaline types. But majority of the industries, especially in telecom industries, we are using the lead acid batteries. The lead, in the sense, it is the electrodes material, the lead, the chemical lead, I can say that. It is the element used for the anodes and cathodes, that is the electrodes. Sulfuric acid is used as an electrolyte. So that is why it is called acid. So the dilute sulfuric acid is suitable for acting as an electrolyte to have a chemical reaction between this lead. So we are majorly using lead acid batteries, but in the recent days we are using a lithium ion batteries also. This is the chemical equations, so that lead oxide and the lead and as well as H2SO4 is getting converted into the lead sulfate. So it is giving a 2H2O, that is water. This is the chemical reactions for both charging and discharging. So in case of the charging conditions, the process will be reversed. So we will be having a lead oxide as a rich chocolate color and the lead as in a light gray color. So just by seeing the electrode, we can able to see the conditions of the charging level of the batteries. These all are equations. Okay. So under the chemical reactions, the hydrogen gas is liberated at the negative plate and oxygen is given off at the positive plate. So once the hydrogens and oxygens are gassing out, that means going out, so that there will be a term called gassing out. So then there will be starvations of the electrolyte. So that is the reason you are pouring the distilled water to each and every cells to regain its charging capacity. So whenever you are having that maintenance of the batteries, you will be having this pouring of distilled water, because the gassing is happening during the charging and discharging course. So to fill the electrolyte or to make the electrolyte to be equipped in a proper conditions, we are pouring the distilled water, so that to make it dilute hydrochloric acid or to maintain the electrolyte positions. So these are comes under the conventional batteries. So உங்க வீட்ல நீங்க batteries யூஸ் பண்ணீங்கன்னா almost I could believe that நீங்க இந்த மாதிரி procedure நீங்க follow பண்ணுவீங்க. Even that very recently in Tamil Nadu that we have alarmed that cyclone alarms வருது இல்லனா வந்ததுன்னு சொன்னாங்கன்னா, they used to say that kindly ensure all your SMPS or your inverter batteries லாம் சொல்லுவாங்க. So then you might have this distilled water லாம் வாங்கி fill பண்ணிருப்பீங்க, அதை ப்ராப்பரா மெயின்டைன் பண்ணுவீங்களா, செக் பண்ணுவீங்களா. So this is what a part of our conventional batteries. So all the batteries are rated in terms of ampere hour is the capacity. இப்போ எப்படி ஒரு வெஹிக்கிளுக்கு நீங்க எத்தனை சிசி வெஹிக்கிள்னு சொல்றீங்களோ, இல்லைன்னா எவ்வளவு ஒரு கிலோகிராம் அப்படின்னு ஒரு விஷயத்த நீங்க வெயிட் சொல்றீங்களோ, லைக் தட் the batteries are rated in terms of ampere hour. ஈவன் if உங்களுடைய மொபைல் பேட்டரிஸ் நீங்க சப்போஸ் கேட்டா கூட என்ன சொல்லுவாங்க 2000 mAh சொல்லுவாங்க 1500 mAh சொல்லுவாங்க. It means what? Milliampere hour is the capacity of the batteries. So what did AH says? Ampere hour in the sense how many ampere it can deliver and how long it can deliver. So that is the unit of the capacity of any batteries, or I can say cells also. Batteries are nothing but group of cells. So AH is the capacity used to mention the how much current it can deliver and how long it can deliver. Say for example, in this slide, if it is a 500 AH, if I am drawing a 50 amperes of current, how long it can deliver that 50 amperes is given by 500 AH divided by 50 is nothing but 10. So otherwise 50 ampere into 10 hours is nothing but 500 AH. That's it. So this is the simplest formula. So the same battery, if suppose I'm increasing the current or I'm reducing the current, so the durations will change accordingly. The same battery can be discharged for 50 hours if I'm drawing only 10 amperes. Clear? So இப்போ உங்க வீட்ல இன்வெர்டர் இருந்துச்சுன்னா சம்டைம்ஸ் உங்களுடைய டெக்னீஷியன் சொல்லிருப்பாங்க, நீங்க ஒரே ஒரு லைட் ஒரே ஒரு ஃபேன் மட்டும் யூஸ் பண்ணீங்க அப்படின்னா உங்களுக்கு ஒரு 24 ஹவர்ஸ் டியூரேஷன் வரும் சொல்லிருக்கலாம். சப்போஸ் இஃப் யூ ஆர் இன்க்ரீசிங் த லோட், எக்ஸ்ட்ரா 2 லைட் யூஸ் பண்றீங்க, எக்ஸ்ட்ரா 2 ஃபேன் யூஸ் பண்றீங்கன்னா என்ன ஆகும்? யுவர் டியூரேஷன்ஸ் will automatically come down because the capacity is fixed, AH is fixed. As your current drawing is increased, so the durations will come down automatically. So 24 hours on the durations, now it will come to only 4 to 5 hours because the currents are increased. So that's the concept. Is it clear? Shall I proceed?
Yes, it's clear. Please
Okay.
proceed.
Thank you.
Sir, if I am using more number of appliances, all will
Okay.
be taking same voltage.
Yes, that is what I said. It is a voltage regulations or voltage drooping. So that regulations will be given. Yes, please.
No,
yes,
my
yes.
question is, suppose if I am using 3 appliances, so all will be taking same amount of voltage, but the current will be more.
Yes. But I would like to point that here the voltages are not the same DC voltages. It will be converted into AC with the help of the inverter, so that the voltages will be of 230 volt. So that
Yeah, voltage is always 230. All 3 equipment will be taking up to 230, but current is increasing. So
yes,
amount the hours will be less.
reduced exactly,
Correct.
because hours AH is fixed capacity, so that the battery can able to have only 500 AH means it can either deliver 50 amperes for 10 hours or 10 amperes for maybe 50 hours.
Okay, understood, sir. Thank you.
Like, understood. பட் ஒன் காஷன் ஐ வுட் லைக் டு சே தட் இதுக்காக நான் வந்து ஒரு 500 ஆம்பியர் எடுக்கலாமா சார் ஒரு 1 ஹவர்ல அப்படின்னு நீங்க கேட்டீங்கன்னா normally which will not be allowed. So we will see in the next slide. That means there will be a over current limiting அப்படின்ற factor இருக்கும். So அது நார்மலா they will design at the time of manufacturing itself. So அதனால நீங்க you cannot, that's the reason if any short circuit happens an immediate fire will catch. ஏன்னா the battery cannot have any particular control. So அதனால the battery has to be properly maintained and properly handled. There should not be any short circuit between these two terminals. Otherwise it will be making maximum current. So நீங்க ஷார்ட் சர்க்யூட் பண்ணும்போது என்ன ஆகும் அப்படின்னா you are just making as a zero resistance, so that huge current will flow and a huge fire may also chances are there. So that so proper precautions has to be taken while handling the cars, especially the people those who are handling the car batteries பொறுத்த வரைக்கும், if they are connecting the cables, so they used to have the metal what I can say, the spanners. So just by tight பண்ணும்போது என்ன ஆகும்னா the positive and negative electrodes may touch, so then immediate fires may be there, sparks will be there. So that proper precaution has to be done, or one side spanner or insulated spanner has to be properly maintained. So with respect to the battery handling, so what will be there inside the cell அப்படி நீங்க பாத்தீங்கன்னா, so it will be having both positive and negative plates will be there, not like an electrodes as we are saying as a testing point, but here we used to say plates. So we'll be having like polarities, or like a positive and negative polarities will be there, which is placed one another. So there will be a spacing, or there will be separator between the positive and negative electrodes. So the negative section being more numbers than the positive. Suppose if I'm having a 10 numbers of positive plates, the negative plates will be always one additional. That is, it will be having 11 numbers of plus negative plates. So if I'm having a 20 numbers of positive plates, there will be 21 numbers of negative plates. இதை நீங்க எப்படி பார்க்கலாம், ஒரு fencing மாதிரி பார்க்கலாம். Fence in the fence எப்படி இருக்கும்னா, if you can able to have only 3 in a down, so you will need to have the 4 fins in the top so to cover all the portions. So the reason for having a more number of negative அப்படின்னா, in order to make use of all positive surfaces to avoid buckling. So buckling என்ன ஆகும் அப்படின்னா, so the positive will be having a chances of uh, uh, what I can say that it will spread it. So ஒரு swelling மாதிரி இருக்கும் அந்த செல்லுல. So to avoid that, to capture all the positive ions, so the number of electrodes or negative ions will be more, or negative plates will be more in numbers. So this is one information we have to understand. So the negative plates will be always in more than positive plates. This is how a battery or a cell looks like. You can see that these all are the black color is the positive plates. So that sandal color is the separator. So that to have a separations between the positive and negative, because it should not touch each other. So there should be only electrolytic flow between the positive and negative. And this gray color is your negative plates. So like that, it will be aligned together and make a complete block, and this block will be filled again. So even though it is a 12-volt battery, a 12-volt cell, inside that it will be having only a small portion. That means it is again connected in series of 2-volt. So normally the primary cell, they used to say about either 1.5 or 2-volt only. Then the 12-volt will be arranged with the help of 6 numbers of 2-volt built together in the cabin or in the container. So this is how the containers and the construction of the battery looks like. But in the recent environments, in the recent researches and studies and the developments, there are various options are coming up in the industries. Even very recently, I could able to notify that in China, the pure water itself is planning to have their own electrolytes, not like acid, sulfuric acid. So even the water itself going to be acts an electrolyte, and various methodologies are going to be adopted for the quick charging, more retaining capacities, light weight, etc. Because the lead itself is cost more weight. That's the reason you cannot able to easily handle the battery. It will be so heavy. So the density of the lead will be so heavy. So that is also one of the reasons. So that to make a weight reduced and as well as quick charging and more retaining capacities, batteries are coming up in the futures. So how we can able to maintain the efficiency of the batteries means it's how much it is discharging and how much it is taking for the charge. So it is a normal output by inputs only. So the efficiency is again designed to work at the normally 90 to 95%. So watt hour efficiency is also another parameter. Watt hour means just in terms of the power. As now in case of electric vehicle, the batteries are now rated in terms of the kilowatt. They are not saying in terms of age. Ampere hour நம்ம வந்து capacity சொன்னாலும் electric vehicle நீங்க போய் purchase பண்றீங்க, அது though it may be two-wheeler or car, they used to say it's only in terms of kilowatt. So that is why it comes under the watt hour. So ampere வந்து இன்னும் பவர்ல கொண்டு போய் வோல்டேஜ்ல கனெக்ட் பண்ணிட்டீங்க அப்படின்னா then it is comes under watt hour. So that is also one of the terms we are using it. One more term I would like to say in this battery part, that is DOD, depth of discharge. So we should not drain the batteries to the bare minimum level, or we should not completely drain the batteries. So then it will lost its regaining capacity, which cannot able to boost its value, or it cannot regain its nature. So there will be a term called depth of discharge. So இப்போ என்னோட 100% இருந்து if I'm reducing the discharge level to the 60 to 70 அப்படின்னா, then there should be provisions to isolate the battery. If it is keep on discharging it more than, or I can say that அந்த 25-10% வரைக்கும் discharge எல்லாம் போயிட்டீங்க அப்படின்னா, then the battery will lose its life. It cannot regain it. So that is a term called a depth of discharge, DOD ன்னு சொல்லுவாங்க. So அதுவும் ஒரு முக்கியமான பார்ட் நம்ம பார்க்கணும். It should not discharge means complete discharge வரக்கூடாது, like short circuit மாதிரியான provisions இருக்கக்கூடாது. So in the conventional batteries, we used to have a hydrometer, so that the charging இருக்கா இல்லையா, அதனுடைய electrolyte capacity எப்படி இருக்குன்னு தெரிஞ்சுக்கணும் அப்படின்னா, we used to have this hydrometer to know the specific gravity of the electrolyte. So hydrometer is used to check the specific gravity, and the normal specific gravity should be 1200. So there will be 1.2 காட்டுது, not 1200 இருக்காது. Normally it will be showing 1.2. And one more point I would like to say in the conventional batteries, where you may be having a constant current charging method. So 14% of the AH value capacity for around 80 hours. இது மாதிரி ஒரு design வச்சிருப்போம். 14 charge means if I'm having a 100 AH, so 14 means the 14 ampere is the maximum current you have to allow. I cannot go for immediately charging 50 amperes because it is designed to operate only in this minimum value of fixed current. So this is comes under the constant current charging method. So 14% of the AH value. If I'm having a 200 AH of battery, I can able to make the charging current as maximum of 28 ampere, like that. So the constant current for the period of around 80 hours, I can able to have the maximum charging capacity. And the cell voltage would be of 2.7 voltage. So these all are the specification with respect to our conventional cells and batteries. Now let us come to the industry part. In our industry, we are not using the conventional because it needs a lot of manpower and maintenance and other spillover environments and etc. things are required. So we are not using the conventional batteries in our industries. We are using a new technology called VRLA batteries, valve regulated lead acid batteries. Here the electrodes and electrolytes are same. They are going to be the same hydrochloric acids and lead, but there is a technology part is introduced so that the gassing will not happen. All the gases left out by the positive plates will be absorbed by the negative plate, so that there is no chances of gassing out. So you no need to pour distilled water. So this is the simplest methodology. So once gas வெளியே போக கூடாதுன்னு ஒரு டெக்னாலஜி நீங்க கண்டுபிடிச்சிட்டீங்க அப்படின்னா, so that அது எவாபரேஷன்ஸே நடக்காது. ஸோ நீங்க அதை டாப்பிங் பண்ணணுன்றதுக்காக ஒரு டிஸ்டில் வாட்டர் நீங்க யூஸ் பண்ணணுன்ற அவசியமும் கிடையாது. So this is the concept of VRLA. You will see. It is a reliable, effective and user friendly. It is spill proof. ஸோ உங்களுக்கு எந்த காரணத்திலையும் ஆசிட் வெளியே தெரிக்கும்னு சொல்ல முடியாது. நீங்க ஹேண்டில் பண்ணணுன்ற அவசியம் எதுவுமே கிடையாது. அண்ட் ஆல்சோ எக்ஸ்ப்ளோஷன் ரெசிஸ்டன்ட். இட் வில் நெவர் வாட் ஐ கேன் சே தட் வெடிக்கும்ன்ற மாதிரியான ஒரு பிரச்சனை உங்களுக்கு பார்க்க வேண்டிய அவசியம் கிடையாது. நோ நீட் டு ஆட் தி டிஸ்டில் வாட்டர். So how it has been designed அப்படின்னா, so it has got some outside like a container material ஒரு டைப் இன்க்ரீஸ் பண்ணிருக்காங்க. அந்த செப்பரேட்டர் நம்ம சொன்னோம் இல்லையா, பாசிட்டிவ் அண்ட் நெகட்டிவ் பிளேட்ஸ்னுடைய செப்பரேட்டர்லயும் ஒரு முக்கியமான ஒரு டேர்ம்ஸ் நம்ம இன்ட்ரோடியூஸ் பண்ணிருக்காங்க. அதுக்கு பேர் தான் AGM, அப்சார்பன்ட் கிளாஸ் மேட்ரிக்ஸ். So this AGM is a material made of some types of chemicals and glass, which is absorbing the maximum ions, so which will never goes as a gas. So all the positive ions are captured by these negative plates அப்படின்னும் போது, so there is nothing is left over, so that you no need to pour a distilled water for the recharging process. இந்த ப்ராசஸ்க்கு பேர் வந்து ஆக்சிஜன் ரீகாம்பினேஷன் அப்படின்ற சொல்லுவாங்க. ஸோ the process or the technology involved in the VRLA batteries are called oxygen recombination. So that is why it is saying about the water loss is roughly 0.1% throughout the life. So then there is no need for topping the distilled water, so that it is completely maintenance free. We used to say that VRLA batteries are nothing but it is a maintenance free. You no need to take care of anything. You have to just clean and see. That's it. And because of the spill proof, we can able to install it in terms of stacks. Stacks means ஒன்னு மேல ஒன்னு கூட நம்மளால அடுக்கி வைக்க முடியும். It will consume a less space. But whereas you cannot do it in your conventional batteries, because it has to have the proper ventilations, proper maintenance. It has got a chance of spillover, so acid and many issues la irukku. But here it is a fully closed container, so we can able to keep it stack over the above, so that we can able to have a minimum space. So like this. So as the diagram shows about, we can able to stack one over the another. So we are having a various capacities also available in VRLA batteries. It starts from even 120 Ah to the maximum of 5000 Ah. Like a very big telephone exchanges or very big data centers or very big transmissions part like nodes and other main data centers, we will be having a higher capacities, so that more loads will be there and it needs for the more durations, so that we can choose a 300 or 4000 AHS batteries are there. Maybe at your field visit you can see and you can able to realize all these informations. Charger connects. So this is the chemical. reactions happening in our electrolyte. So here we are having an, as I said, it is an oxygen recombination process are getting happened, so that it never expect the topping of distilled water. This is what I said, oxygen recombination. In VRLA battery, here we are using only a constant voltage charging methods. So earlier in our conventional, we have designed, we have discussed about the constant current charging. It is around 14% of the AH. But here we are using only the constant voltage. So we have to understand that the current may vary from minimum charging to the maximum charging. So when the batteries are completely drained, it will take maximum current. Once it is keep on charging, if it reaches to the maximum charging, the current will be of reduced. So because of the constant voltage charging, the current will vary from higher to the lower value. So the charges voltages are around 55.2 voltages, and voltage per VPC stands for voltage per cell. So here to make this 48 volt battery, we will be having 24 numbers of 2-volt cell connected in series to make the 48 volt. So that individual 2-volt cell can be able to have the maximum charging voltages of 2.3. So that is why 2.3 is a voltage per cell, and 2.3 into 24 will be getting 55.2 volt as a whole output. Then I said, right, so I cannot able to increase the current as by the capacity. There should be limitations. Normally 20% of the AH will be restricted. If I'm having 100 AH capacity, so my maximum current is allowed to be only 20 amperes. I cannot charge it for 50 amperes, or I cannot able to charge for 80 amperes, because the current, if it goes more, it will be having a more heat, and it will be creating a lot of other problems, and there will be chances for fire also. So there will be restrictions for charging current. As 14% of the constant current methodology, here it is a 20% of the AH in case of the constant voltage method. So this also we have to make a note of it. But in majority of the industry, we will never even go for 20%. We go for 10% of the AH only. This is what the example says about. So the charging here, I'm having a maximum of 0.2, but the widely accepted charging methods are only 0.1, that is 10%. So if it is of 2000 AH of capacity, if I'm charging at 20%, I can allow maximum 400 amperes to charge. If I'm adopting only 10%, then I will be having only 20% of the ampere to cross. So that the maximum allowed current is only 20 amperes. 200 amperes if I'm following a 10% of the capacity, AH capacity. Is that clear, sir? Because based on the current only, I have to design the equipment, power plant, cables, etc., etc. And the current also can create the heat and other losses. So that is the reason it will be restricted to either normally prescribed 20%, but industry point of view, it has been accepted to operate only 10% of the capacity. Is it clear? Okay, thank you. The charge intervals will be there. The ideal cell be should only at least once in a 6 months. Even though sometimes we may not put the cells in the load, so it will still in ideal. So at least it has to be charged on. That is why while purchasing the batteries in the market, you have to see the date of manufacturer. If it is a very old date, so then it may lose its positions, or it may lose its regaining capacity, or it may have the lesser efficiency. So, and also the distance is also one of the matters. So from where the supply is getting connected to the load, because it will be connected through the DC cable. So there will be a small voltage drop, as an resistance will be there in the DC, and the I square R loss will be there. So 30 millivolt per meter will be a voltage drop, so that the proper planning and the proper thickness of the cable and the proper spacing and distance has to be maintained. So to have this battery, power plant, and load capacities. And the temperature should be also around maintained of around 25 to 29 degree. And normal ventilation is sufficient. It not required any AC or fans or etc. So normal ventilation is required. So in case of the fresh charging, That is, at the very first time you are doing this charging means they used to say that it has to be charged for nearly 2.25 volts per cell for 30 hours, or at least boost voltage. As I said, that there will be a higher voltages per cell, that is boost voltages for 12 hours. If you want to make it quick utilization, you can go for boost charging. So in terms of our telecom industry, we used to have these types of records. So though I said it is a maintenance free, but there will be some records and which are used to maintain the batteries. So we used to have the individual cell voltage. So we allow the battery to handle the load. That means we'll switch off the mains and we allow the batteries to handle the load, and we will take the individual cell voltage, so that which will give the performance of the individual cell voltage. If every cell is in a good condition, so we will be getting 2 volt per cell in all the cells. If any weak cells are available, then that particular cell it will be showing either 1.3 or 1.2 or even 1.5, so that we can able to identify which cell is in the poor state. Then either we can take the action like we can remove that particular cell, either we can try for the boost charge, or we'll replace that cell. So with the help of these individual cell voltage informations, we can able to identify the weak cell and we can take the preventive measures to replace it. So these are the basic steps we will use to maintain in our exchanges. Hope that I have come to the proper time and I have taken your extra time also. So thank you very much for your interactions, and you have made a great interaction with me through both voice and as well as the chats. So thank you very much. So now I'm feel free to answer of any of the clarifications or any doubts with your sides. I will share this PPT also through your WhatsApp group, so you can express your feedback. So thank you all. Thank you all for your patient listening and your valuable time, and as well as having a trust on BSNL and its training part. So that thank you very much for your presence and your interactions also. So if is there any no doubts or if no questions, so the participants can take a leave. So I will be there for 1 or 2 more minutes, so that I will also quit the sessions. Thank you very much, sir. Thank you, sir. Thank you. Thank you. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you for the excellent
Thank you.
explanation, sir.
Thank you, sir.
Thank you, sir. Thank you. Thank you.
Sir, I have a doubt.
Yes, ma'am.
Sir,
Yes, ma'am.
is
Please.
all the
Yes, ma'am.
equipments working? Does all the equipment work at the minus 48 voltage, sir?
Yes, ma'am. All the telecom equipments are designed and manufactured to work at only minus 48 volt, because it is a global standards. I can say that like how these all the home appliances are designed to operate at 230 volt AC or 440 volt AC. So like that, telecom equipments are also designed to operate at minus 48 volt DCs.
Can you name some equipment, sir? I'm eager to know that.
No issues at all. So I can say all type of switching equipments. So switching equipments mean these equipments are working for our voice communications. All the transmission equipments, maybe optical fiber cable communications equipments like ADMs, SDH, that means air drop multiplexers, DWDM equipments, CPAN, and these all are the short forms of the equipment names. So all the transmission equipments are designed to operate at the minus 48 volt. Now
We
let
will
us
be
come to the, yes, ma'am.
Sir, we will be learning about all these equipments, sir.
Yes, sure. If you are going to the exchanges and field, you will be seeing about, and even in the due course of training also, you will be informed all these equipments.
Okay,
So
sir.
there are n number of parts are there. One is like a data network. Suppose even if you are getting the broadband or the fiber connection of internet, so that equipment is called OLTE. That is designed to operate only at minus 48 volt DC. broadband we will be having a DSLAM equipments, so which will be having again operated to minus 48 volt DCs.
Thank you, sir.
So all the telecom equipments are designed and manufactured and standardized to operate at minus 48 volt DC.
Thank you, sir.
Thank you. Thank you. Thank
Nice
you.
presentation, sir.
Welcome, madam. Thank you. Gilla.